well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft. So in the previous video, we have already taken an introduction about what exactly are we going to cover in this module. So let's get started with the very first video where we talk about CPU scheduling. Before actually moving forward, we'll take a quick recap and we talk about why exactly do we need scheduling. So a typical process involves both input output IO operations as well, right? And as well as it does require some CPU time to do some computations as well. Now, in a uni-programming system where we are only executing one program or like a single process, like MS-DOS, time spent for input output is wasted, okay? And CPU is free for that time. So what happens is in a system like uni-programming system, for example, MS-DOS, wherein only one program is basically or one process is executing at a time. So if that process went into the waiting state, right, then no other process can enter into the CPU execution or the running state, right? Because of which, if the program is in waiting state, it is waiting also. So it's not doing anything. And as well as the CPU is also free at that time. Okay, so what we do is we introduce the multi-programming system, wherein if there is a process which is waiting for a particular input-output operation and the CPU is free at that time, instead of keeping waiting and keeping the CPU free, we actually utilize and introduce another process in the system which can take up the CPU resources. Okay, and this is only possible if we do the process scheduling. Right? So as we have been talking so far already in previous modules as well, that we always want to keep the CPU utilization to 100%. So we never want to keep a CPU free at any point of time. If a process is not in the execution state and it actually in a waiting state, we want to make sure that some other process is being executed at that time so that the CPU utilization or CPU is being utilized at all points of time. So then the concept of CPU scheduler basically comes in. So what happens in the concept of CPU schedulers is there are a lot of processes which are in the ready state, right? And we actually choose a process among all of these processes and we basically start the execution for that process and brings that into the running state. And when we bring that process into the running state, we actually allocate CPU resources to that process which was selected and the execution of that process happens. Okay, so this process of selecting, right, the process from a ready state and bringing it into the running state is known as the concept of CPU scheduling, and we basically allocate CPU to the selected process. Now the CPU scheduling decisions, right, always takes place under one of these following four situations, meaning only when one of these four situations happen, then the CPU has to take a decision or the CPU scheduling has to take a decision as in what process to select. Okay. So let's say where there is a process which went to the running state. Now from the running state, that process goes to the waiting state. So now we need to make a CPU scheduling decision as to which other process will now go into the running state, because the process which was already running is going to the waiting state. Okay. Now in another situation, when a process basically switches from the running state to the ready state. So sometimes if you remember, there are some CPU operations or there are some interrupts that happen, due to which what happens is a CPU is forcibly asked to let go of its resources and it goes back to the ready state. In that state also, or in that situation also, a process which was in the running state is now no more in the running state and the CPU cycle is supposed to be free. So in that case also, we want another process to come into the running state. So that is when also you have to take a CPU scheduling decision. Okay. In the third case, what happens is if there is a process which was already waiting, right? Now there is a process which was waiting for some input output or some external event to happen. And let's say after some point of time that external event does happen. Now what will happen is since that internal or that external input output operation has been completed, the process which was in the waiting state will now go into the ready state. In that situation also, we have to take a CPU scheduling decision as to which is the next process which will get the input output resources which are available. Okay. And the fourth situation is when a process is in running state and it has executed its last statement, then also it will go to the termination state. In that situation also, the CPU is now free and we need to make a CPU scheduling decision as to which next process should be executed. Okay. So this is very, very important, right? In all of these four situations, you have to take a CPU scheduling decision. All right. Now remember the circumstances 1 and 4, right? There is no choice in terms of scheduling. Okay. A new process must be selected for execution. So in situation 1, wherein a process goes from running state to the waiting state, and when a process terminates. In both of these situations, a new process must be selected for execution. Okay. Whereas if we talk about the situation of 2 and 3, it would be known as a scheduling which is preemptive. So now we actually introduce two terms over here. We introduce the term non-preemptive and we introduce the term preemptive. Okay. So scheduling 1 and 4 is known as non-preemptive scheduling, and 2 and 3 scheduling is known as preemptive scheduling. Okay, so what we'll do is we'll first actually take a look at what exactly is the meaning of preemptive and non-preemptive scheduling. Okay, like I said, the scheduling or the entire scheduling process can be divided into two parts, preemptive and non-preemptive. Okay, so let's take a look at all of them in detail one by one. Preemptive is the point 2 and 3 where you go from running state to the ready state, or you go from the waiting state to the ready state. In both the situations, a process is going back to the ready state. Okay, so whenever we talk about preemptive scheduling, right, in this type of scheduling, the tasks are mostly assigned with their priorities. Okay, sometimes it is important to run a task with a higher priority before another lower priority task. Okay, even if the lower priority task is still running. Okay, the lower priority task holds for some time and resumes when the higher priority task finishes its execution. Let's take a very real life example, and it happens quite frequently as well. Let's say you're going down a road. Okay, you are at a position A, that's the source, and you have to go to the destination B. In India, what happens is whenever you have to go from a source to destination and you're traveling by road, but let's say there is a very VIP person or a very high valued minister who's also traveling across the same road. So what happens is, because of that, since the priority of that person is high, that person is allowed to pass through first. Okay. Similarly, you can also take an example of an ambulance. When you're going down the road, you are also going down the same road, and let's say an ambulance is also going down the same road. But since the priority of an ambulance is more, that is why the ambulance is allowed to pass through first amongst other cars. So your car might actually be in front of the ambulance, but since the ambulance has a higher priority, your car will be stopped for some time and the ambulance would allow to be first finish its execution or reach to its destination. And when the higher priority task completes, then the lower priority task is allowed again back to get executed. That is the concept of preemptive solution. So in preemptive solution, the task mostly has priorities assigned to them. Okay, and sometimes it does happen that there is a certain task that has a higher priority before other tasks, and it has to be executed first, even though a lower priority task might already be executing. Okay, so because of which the running task is basically interrupted or halted for some time, and then it is resumed later when the priority task is finished. Okay. This type of scheduling is basically used when a process either switches from the ready state to the waiting state, or it basically goes from the running state to the ready state. So only the preemptive kind of a scheduling decision happens when there is a process in running state and it goes to the ready state, or it was in the waiting state and then it goes into the ready state. So only when the processes are going towards the ready state now, that is the way or situation where the preemptive scheduling happens. Okay, the resources are mainly allocated to a process for a limited amount of time and then they are taken away, and after that the process is again placed back into the ready queue, in that case if that process still has some time remaining to get executed. Okay, the process stays in the ready queue until it gets the next chance to execute. Okay, and we have some scheduling algorithms that we will discuss later, which are preemptive scheduling algorithms. Okay, next what we have is the concept of non-preemptive scheduling. Okay, so what happens in the concept of non-preemptive scheduling is that the CPU has been allocated to a specific switching the context or terminating. So if as a person, right, I got on the road, right, then either I will stop the car when I have actually decided to switch or change my destination, or either my destination is reached. Okay, in the world of programming, in the world of operating system, we say that a process has been allocated a resource and it will not leave the resource irrespective of the fact of outside resources. It will only release the CPU resource either when it switches the context, that means it goes from a ready state to a waiting state because it requires an input output operation, or the process is actually completed. Okay, it is the only method that can be used for hardware platforms. That's because it does not need special hardware like preemptive scheduling. So in preemptive scheduling, you give the priority task some time to get execute, a particular period of instance, and then you take the resource back. But here nothing like that happens. We do not require any special hardware. Okay, this scheduling methods is actually used by Microsoft Windows 3.1 and actually by the Apple Macintosh operating systems as well. Okay, here in non-preemptive scheduling, it does not interrupt a process which is running in the CPU in the middle of execution. In preemptive scheduling, if a process is running but a high priority task comes, an interrupt will happen and your process will be stopped. But in case of non-preemptive scheduling, the process is not stopped in between. It is not interrupted in the middle of execution. Instead, it actually waits till it actually completes its CPU cycle, and then after that, the resource is allocated to some other resource. Or maybe if you are using a timer kind of a structure, so when your timer will end and the context switch will happen, then some other resource or process will get the resource. In any other situation, you cannot just halt or interrupt the process in between. So we'll also take a look at some processes which are non-preemptive, or like some algorithms which follows the concept of non-preemptive scheduling. Okay. So whenever we'll talk about the concept of scheduling, always remember these are the scheduling criteria that we need to make sure are present in all the scheduling algorithms that we take a look at. Okay. First is CPU utilization. We want to keep the utilization 100%. We want to make sure that the CPU is utilized as much as possible. Okay. Along with that, the arrival time, the time at which the process arrives in the ready queue, is known as arriving time. Okay, we'll take a deep look at these timings as well. We'll just take an overview over here. Completion time is that the time at which the process completes its execution. The burst time is the time required by a process for the CPU execution. How much time do you require the CPU cycle is, right, basically the time required. Throughput is the number of processes that complete their execution per time unit. Turnaround time is the amount of time to execute a particular process, total time, okay, including the waiting time as well as the burst time. Waiting time is the amount of time that a process is waiting in the ready queue. And the response time is the amount of time it takes from when a request was submitted until the first response is produced, not the output. The first time you gave the input and the first time you received the response. Okay, that is what typically what the idea is over here. Okay, always make sure that the entire purpose of the scheduling algorithms is so that you maximize the CPU utilization, you have a fair allocation of CPUs as well. Okay, so let me just write down the purpose as well, although we have taken a look about this a little bit in detail when we were doing processes, but let's still define it again. What are the purpose of scheduling algorithms? Okay, so here we want to make sure that we have the maximum CPU utilization. We also have fair allocation of CPU. It's not like only one process is getting CPU all the time and the other processes are not able to get it. We want to keep the throughput maximum. Okay, we want to keep the turnaround time minimum. Okay, turnaround time is the total time it takes for a program to process to execute. Okay, including the waiting time and the burst time. And then we want to keep the waiting time also minimum. We don't want a process to wait a lot in the waiting queues. Okay, we want to make sure that they wait as less as possible so that their overall turnaround time decreases. And we also want to keep sure that the response time for any request is also as low as possible. Okay, don't worry about all these terminologies. Okay, we are going to take a look at all of them in detail through an example in the next video. Okay, so it says over here as well, for the optimization criteria, we want the maximum CPU utilization, maximum throughput, minimum turnaround time, minimum waiting time, and minimum response time. Okay, and with that, these are all the scheduling algorithms which we are going to discuss in our future videos. We'll talk about first come, first serve. We'll talk about priority scheduling. We'll talk about shortest remaining time algorithm, shortest job first algorithm, round robin scheduling, multi-level queue scheduling. We'll not go into all of them in detail. We'll discuss the important ones with great emphasis to their way that these algorithms are being used. Okay, so this pretty much forms our I would say the building blocks that would be required when we actually move ahead and talk about different CPU scheduling algorithms. So what all did we discuss in this video? Let's just quickly summarize. We first talk about why did we really need scheduling? What's the purpose it basically served, right? And it basically, the idea is that we want to make sure that the CPU is never free and its utilization is maximum. Secondly, we want to make sure that we want to understand that when does the CPU scheduling decisions basically happen. When in a process is in a running state, it goes to terminate, or in a running state, it goes to the ready state, or in a running state, it goes to the waiting state, or it was in a waiting state and it goes to the ready state. In 4 of these situations, we basically have to take a CPU scheduling decision as to which is the next process that will execute. Situation 1 and 4 is non-preemptive, whereas situation 2 and 3 is preemptive. Okay. Then we talked about what exactly is preemptive and non-preemptive. Preemptive is when every task has a priority assigned to it. And if the task has a higher priority, it will be executed first, and the usual task is actually halted and the high priority task is actually executed first. So an interrupt happens where an execution of a task or a process halts in between. Okay. In non-preemptive scheduling, there is no such kind of priority understanding wherein a CPU will or a process will keep the CPU busy either till the time it terminates or it switches the context. And here we do not keep a timer kind of a structure because here there is no concept of priority. And then we talked about a few terminologies, which is CPU utilization, arrival time, completion time, burst time, throughput, turnaround time, waiting time, and response time, for which the examples we'll take in detail in the very next videos. Okay. Arrival time when the process comes in the ready queue, completion time when the process completes, burst time is the time duration required for the CPU execution, throughput is how many processes you could execute in a per unit time, turnaround time is basically the waiting time when you were waiting in the queue plus the burst time when you were actually using the CPU resources. So the entire amount of time it takes to execute a process, and the waiting time is when you are waiting in the ready queue. And the response time is the first amount of time it takes to give you the first response from the first time you gave a request. Okay. And with these things, we want to always keep in mind that the CPU utilization is high, the throughput is high, you can execute more processes in a per unit time, the turnaround time, that means the total time it takes to execute a process, is low, the waiting time is also low, and the response time is also low. Okay, and with this, we will start our discussion for all these algorithms in our next video. Okay, some are preemptive scheduling algorithms, some are non-preemptive scheduling algorithms, and we will talk about all of them in detail. Okay, so with this, let's end the video right here. Thank you so much for taking a look at this video. I hope it is clear to everyone and you have a fair amount of idea about the basic building blocks of scheduling algorithms. In the very next video, we are going to take a look at the first scheduling algorithm that we will take. But before that, we'll also understand all the times, right? Arrival time, response time, turnaround time. We'll also take a quick introduction about all of those as well. So stay tuned for all of these videos. Keep practicing. Make sure you understand each and every concept and move ahead. Thank you.